Alright, this is example 2 of partial fractions. Okay, again, all we're doing is some algebra to break this fraction into separate fractions. Okay, it's easier to integrate those as long as you remember how to integrate natural log or answers that look like natural log. Alright, so first thing I'm going to do is just rewrite it. I'm doing some algebra here. Well, right now I'm just copying. Okay, what are the factors of x cubed minus x? If you're not good at factoring, so take out an x, that'd be x squared minus 1, so that means it's x times x minus 1, x plus 1. So that's all my factors, x minus 1, x plus 1, a, b, c. Alright, now, if we multiply through by the common denominator, we made a mess over here, so it'd be 3x squared minus 7x minus 2. So on the left-hand side, if you multiply by the common denominator, just the denominator goes away. On the right-hand side, you're going to be just tagging on the missing factors, right? So here, x is missing the x minus 1, x plus 1. So a gets multiplied by x minus 1 and x plus 1. And b gets multiplied by x and x plus 1. And c gets multiplied by x and x minus 1. All right. Rewrite this, make sure I remember that's a 7. Alright, now you're going to choose values for x so that it wipes out one letter at a time, A, B, or C. You want to get rid of those. Alright, so in this example, x is not, well, alright, so I'm going to let x equal 1. Let x equal 1. If I let x equals 1, what happens? If I let x equals 1, remember you got to plug in the left-hand side too. So that's going to be 3 minus 7, which is negative 4, minus 2 is negative 6. Double checking, negative 9. Okay. If I plug in 1, so this gets wiped. Oops. And this gets wiped. So I plug in 1 here, that's going to be 1 times 2, so that's 2b. So b equals negative 3. Okay? In case you missed that, so 1 plus 1, remember I'm going to let x equal 1, so 1 plus 1 is 2, and 2 times 1 is 2, and then 2b. So that's where that 2b comes from. And then solve for b. Now let x equal negative 1. This is arbitrary. You don't have to do this in the same order. You could start with negative 1. Alright, plug in negative 1. That's going to be 3 plus 7 is 10. Minus 2 is 8. Okay. Double checking. 3 plus 7. Remember, it's plus because it's negative 1 times negative 7, making it plus 7. 3 plus 7 is 10. Minus 2 is 8. Plug in negative 1. That wipes that out again. Wipes that out. Now it gives me C. So that's going to be negative 1, negative 2, right? Negative 1 minus 1 is negative 2, times negative 1 is positive 2, so it's positive 2C. So that means C is 4. And then we let x equal 0. 0 is going to wipe out these two. And I just have this one. So it'll be negative 1 times positive 1. Oh, let's go. Plug in 0. This gets wiped. This gets wiped. And so that's negative 2. And plug in 0 here, negative 1 times positive 1 is negative 1, so it's negative a. That means a is positive 2. Alright, so that's the numerator. So I'm going to just go ahead and write it. Since I don't have fractions, I'm going to go and just write it. Okay, so a equals 2, so 2 over x. So that's what I've done. I've replaced the a with 2, plus b is negative 3. Oh, I guess I should have made a minus. Negative 3 over x minus 1. That's up here. And c is 4 plus 4 over x plus 1 dx. Oops, sorry. So let's say it again. So a is 2. I replaced the a with 2. B is negative 3. So I replaced the b with negative 3. C is 4. C is 4, right? And I replace the c with positive 4. Now we integrate this. When we integrate it, we get 2 times the natural log of absolute value of x minus 3 times the natural log of x minus 1 plus 4 times the natural log of x plus 1 plus c. Alright, I don't know why it's kind of fuzzy up there. Alright, now this can be written as one fraction, I guess. But maybe not, because of these 2, 3, and 4. it does weird things. So this can be written as natural log of x squared minus natural log of x minus 1 to the third plus natural log of x plus 1 to the fourth. So this has the minus, so this goes in the denominator, and these go in the numerator because they're positive. So it's natural log of x squared times x plus 1 to the fourth over x minus 1 to the third. And I do need to keep the absolute value because of this term, right? Because at odd exponent, you can have negative numbers come out. Let's see. All right, so this was mostly algebra. There was only one calculus step, and that was the integrating here. So the rest of it was algebra. Okay? All right, that's example 2.